Hello everyone and thank you very much for watching this event, lesson number 24 from the Java Fundamentals stream. So after finishing this lesson you can already say that you might go on one full day marathon with Java, and the good news is that we will not stop here, so we have plenty of things to discuss further. But thank you very much for helping me arrive at this point. Only with your help and with the fact that you have subscribed lots of you have subscribed to the channel, we could get to this point. So let's continue with the today's lesson, that is about java.lang classes. Of course, we won't discuss all the classes from java.lang in this lesson. Maybe the title is a little bit confusing. We will start with the classes from java.lang today, but we will have too many to discuss, so that we can do that in only 1 hour. We have to discuss about math, system, string buffer, string builder, all the exception and error, the throwable tree from inheritance tree from the java.lang, together with the syntaxes for catching and throwing exceptions, and the wrapper classes, of course. So we have a lot of things to discuss from now on from the java.lang package. We just start in this lesson with the java.lang. By the way, don't forget that if you are watching the event live, you can ask questions in the live chat. I always have an eye on my live chat. And if you are watching the event recorded afterwards, you can still ask questions in the comments section, or you can simply follow me on LinkedIn or Twitter and you can ask me the questions there, and I will either answer your question in the next video. If you are leaving me the question after the event, I will either create a separate video for you or in the next lesson. So thank you very much again for all your questions until now, because they were really great and helpful for everybody following this channel. Okay, what is with java.lang? So again, I have a project here using version 13, as you can see, and this is the latest Java version. We mostly discuss in terms of Java 11, which is the latest long-term supported, but I always use the last version. Anyway, the difference are not big in regards to what we will discuss in the in this lesson and in the next lessons. And we will talk more about classes from the java.lang package, which is actually part of the Java base module. So if you are using a version that is later, Java 9 or later, then you will have modules. You will have a modular JDK, as we have discussed in the previous lessons when we talked more about modules. And you know that Java base is actually a module that you don't have to require. So even if you have a modular application, you don't have to specify that you require the Java base. So the Java base module is automatically required by any module that you declare. So you can use the packages from the Java base without needing to specify the require on the Java base. And if you go into Java base, you will see that you have multiple packages. So the one that we are interested on now is java.lang. So you see it here, java.lang, and inside java.lang we have a lot of other classes, and part of these classes is also what we will discuss. So again, it's about the math class, system class, all the wrapper classes, exceptions, and when we discuss about the exceptions as classes, we will discuss also about all the syntaxes, and of course the object class, that, as you will see, is the parent of all the objects in Java and is automatically inherited by any class. And we will learn how to override methods from the object class, and which are the methods and which are the rules for these methods in terms of overriding, so that you can do that for all your real world scenarios, as well as all the details that you need to know for your OCP 11 certification exam. So java.lang, similarly as Java base, it is a package that is automatically imported. You also know that, as well as you have to require a module in order to use the packages that are exposed by that module, as we have discussed in the previous lesson. Some time ago we have discussed about packages as well, and you know that in order to use classes from a specific package, you have to either import those classes in your Java file, or you have to specify the class together with the name of the package whenever you use it. And in terms of java.lang, this doesn't apply because java.lang is again automatically imported, so classes that are part of this package are considered to be so used, so part of any needed application, such that the classes and the classes in this package are automatically imported. So you will basically never see an import of java.lang because that's redundant. You can do that if you have a question in your OCP 11 exam that states that a specific class from java.lang is imported. This is not wrong, it works, it compiles, but it is redundant. You don't have to do that in a real application. So that's why in a real application basically you won't see an import of a class from java.lang. So to give you the first example, let's just create a separate package, example1, and inside example1 let's create a class example1, of course, and in this class we will have the main method. And as you know already, you have seen in all my previous lessons, you already use this string class here, and we know from actually one of the first lessons that string is not a primitive in Java. So that means that this is actually a class, and this class is part of the JDK. You can basically find this class in java.lang, so this is why you don't have to import anything to use string. The same rule will apply to all the classes from java.lang. So for example, you might actually write the import here, java.lang string, and this works. You can do that as I've said, but it's redundant. No matter if you write or not the import, it will still work with classes that are part of the java.lang. So this is why, similarly as with the Java base module that we say that is automatically required, you don't have to require it explicitly. In case of java.lang, the classes are automatically imported, so you don't have to import them explicitly. If you do that, it is redundant, but in most of the cases you won't see that, maybe only for very old examples or for exam questions where they want to state explicitly that, and you have to know it because it's part of the language. So with that being said, let's start with discussing the classes that are important from java.lang. I will not take all the classes. You won't need to know all the classes, but you have to be aware of some of them for both using them in your real case applications as well as for your OCP 11 exam. And the classes that we want to discuss, I will put them in a comment here so that you know what will we follow from now on. We will discuss about math and we will discuss about the class system, and we will discuss also about the class named object, which you will see is one of the most one very special class in terms of the fact that it is really the only class that doesn't inherit anybody. All the other classes we will learn that inherit at least object. Even if you don't specify the extends clause, it happens out of the box, it happens automatically. So it's a very special class from this point of view. And we have all the wrapper classes that are representing the primitives as objects, and so we have 8 primitive types. You already know that, so that's why we will have also 8 wrapper classes, and you don't have to know them at the moment, but I will enumerate them so that you know that we will discuss about them. It's byte, short, integer, long, float, double, character, and boolean. Do we have 8 here? Yes, we have 8. It means that it's all of them. So this we will take them in a separate lesson and discuss about them and which are the important methods out of them, and all the characteristics which you will see. They also have some special characteristics, these wrapper classes. We will discuss all about them in a separate part of one of our lessons. And then we of course have to discuss all about strings. So we have the string and we have the string builder at least. And then I will also mention here string buffer, which is really similar to string builder, but it has some differences, especially in terms of synchronization and threads. So for the first C, you will just or I will just tell you to simply see them as almost identical. So just think about them being similar, being equal, but you will see they are not basically equal in all the terms. So we will at some point discuss also some differences about string builder and string buffer, but they are basically the classes that you will mostly encounter in terms of strings in working with strings in Java. So we will discuss them in detail, starting with this introduction in java.lang. And again, this won't happen only in this lesson, because we don't have 1 hour, or we might try to do that, but then we won't cover all the details that you need to know for working with those classes, as well as knowing the important things for your OCP 11 exam. And one more thing to tell you before, it's also, did you see that wrapper classes don't contain the strings? So you will see that it's some kind of a confusion I've always seen for juniors, especially people starting learning Java. They make confusions between the character class and the string class, and they think string as being one of the wrapper classes, but it's actually not. So this is why in my case it's written separately, because indeed string is not a wrapper class. We will discuss this again in detail when we get to that subject. And we have all the exception hierarchy. So we have throwable, and we have exception, and we have error class, and we have the runtime exception. And we will discuss a lot about exceptions separately, with all the syntaxes needed for treating and throwing exceptions in Java, together with these classes that again are also part of the java.lang. So you see, we have actually a lot of classes that we want to discuss, and a lot of concepts about these classes that are part of java.lang and that we will take in detail. So being that said, let's just start with our first class there, and let's start the discussion with math and see what is special about this class, what should we know about this class, and as well as what should we know about it in terms for the OCP 11 exam questions. So the math class is basically a really easy to understand class, because it's only an utilitary class. An utilitary class is a class that only contains static fields and methods, and usually when we create a utility class, we make it final, so that it can't be inherited. You know that the final keyword used together with classes doesn't allow anymore the inheritance of that class. And also it usually declares a private constructor such that nobody can create instances of that class. So the class can be only seen as a container of some static fields and methods. You won't create instances of that class. You don't need to inherit that class. This is an utilitary class, and each static method it's only designed to be an operation that you can call by the means of the name of the class. So the same way we have learned many lessons ago, where you know that to call a static method or field, you just use the dot operator from the name of the class directly. So you will basically write something like this, and then you can, for example, obtain the absolute value of a specific integer, long, double, whatever, by using for example this ABS method. And what does actually the math class contain? What are those operations, those utilitary operations? So this is they are basically the most encountered simple mathematical functions that you might need to use with different algorithms. So for example, the absolute value of a number is part of the math class. In the math class you will as well find the square root, cubic root, power of a number, roundings of the numbers. You will find even a method that allows you to generate random values, but I will tell you later that usually you don't want to use that one with a real case application, and I will explain at that time why shouldn't you use the random from the math class. You have all the trigonometry methods like tangent, sinus, cosinus, and so on. All the basic mathematical operations, simple operations that you usually apply to one or more numbers, and you want to obtain a result out of them. So in order to see the most important, I don't think it's really quite important for you to see me here system out printing some results of these methods. You can trust that they are implemented correct in Java and they really return the correct results. So for example, the absolute value of -10 should be 10. But let's just go through the documentation and see and explain very shortly the methods that you need to know, especially in this case for the OCP 11 exam. So I have already basically opened here the specifications, the API specifications from the Oracle JDK for version 13, and here I have already searched for the math class, so we can see in the documentation, and maybe it's the time to tell you also a little bit about this documentation. The way it is generated is by using an utilitary tool that comes with the JDK, and it's called java.lang. And this is why you will find that all the Java documentations basically look the same. They have the same style because they are web pages. They are simple static HTML pages actually that are generated by this java.lang tool. And what do you actually find in a documentation like this? You usually start by finding, of course, the name of the structure, and then you see if it is a class or something else. Maybe it's an enum or some other kind of Java structure that we have discussed. And then you can see the module to which it belongs. You can see the package to which it belongs. Since Java 9, it also has this very nice search here, so that you can search very fast through all the packages, modules, and classes in the documentation. In Java 8 and before Java 8 you didn't have this search here, and of course some things are different, like for example the modules. We already know that they are only part in Java starting with Java 9. So yes, if you will use the Java 8 documentation, so it will look in a little bit different from some points of view. So we have here the class and the name of the class, and we have the inheritance chain, so we can see who is math directly inheriting. In this case is directly inheriting the object class. We didn't discuss yet about the object class, but again you will see this is basically the class inherited directly by any other class, and directly inherited by classes that don't specify any extends clause. And you can see the definition of the class itself. It is important whenever you look into the documentation. You can see, for example, if the class is final, is exactly what I've said a little bit earlier, that this class is designed as an utilitary class, and the utilitary class is marked as final so that it can't be inherited, and it has a private constructor such that all the constructors are hidden inside the class. You can't use them from outside to create instances of the class, because the only purpose of an utilitary class is to be a container of these static methods and fields. And you see basically if it's extending a class or interfaces, you can see who is extending, and then you have a short description of the class. And sometimes you want to see also since which version this class exists. Of course, the math class, it started to exist with the first Java version. And then you have all the fields, methods, constructors, nested classes, and so on. you have everything about all the elements declared inside that class. So for example, in math class we have two fields, both of them are static and they are defined as double, and one of them is called e, which is the Euler number and which is the base of the natural logarithm, and we have also pi, which is the ratio between the circumference of a circle and its diameter, and you use it for the computation of the area, for example, or anyway, a lot of computations, a lot of mathematical equations contain the value of pi. If that is a question, Andrei, so object is the root of all the inheritance tree. Yes, this is correct. Object is the class, and I will discuss it in detail after we talk about math and system. Object is the class that is inherited by any other class directly or indirectly, so that makes it the root of the inheritance tree in Java ecosystem. That basically means that object is the only class that doesn't inherit anybody but is inherited by everybody else. So we will see the way, and because of the fact that classes cannot inherit multiple other classes, this becomes a tree, and object is indeed the root of this tree. So yes, it is. And if you go to it, let's just go and see what it contains. If you load this class, you will see in its inheritance, it's the same here. Under the name of the class you have the inheritance chain. You will basically see this is the only class where that doesn't have anything above. So this is its own inheritance chain. It's just the object class. It doesn't inherit from anybody. But if you go and try any other class, like literally any other class that you would find, we will see from all the others, you will see any other class has at least one class above in the inheritance chain, and that is the object class. At least one. Of course it can have multiple, but at least one of them is object, and that is the top of the inheritance chain. So we have these two fields which are double, and then we have a lot of methods. As you can see, some of them are overloaded. So the reason for why you see, for example, it's done also for long but also for int is basically for performance reasons, because maybe you wonder why would it matter if you anyway create for long, then it would apply as well for int, because you already know that Java can automatically do some conversions between some primitive types. So for example, an int can be easily converted to a long. So maybe you are asking why would I create two methods, in this case one for int and another one for long, if this one was enough for both of them. So it's in this case, when you see something like this, is usually done for performance improvement, so that you have two different methods, and whenever you call it with a long, it would go to this one, and whenever you call it with an int, it will go to this one. So that's why you have sometimes multiple overloadings, and some of them even might look redundant, but they are done like this for performance reasons. And then you have the absolute value, and you have trigonometric functions like cosinus, arccosinus, arcsinus, and so on. You have the cubic root, you have ceil, which is an approximation to above. You have for example, the exponential function. So you want to apply an exponential function to a specific number. Then you have the floor, which is an approximation to below. You have basically logarithm this is the logarithm, the natural logarithm, the logarithm in base 10. You have the maximum and the minimum between two values as well. You can use the operators smaller or equal and so on for them, but you will find also a method in a math class for them. If you want, you can use the method from the math class. And then we have basically a lot of methods, all of them representing basic operations. So you don't have to go through all of them, you don't have to know them by heart. The idea is just to understand and remember what can you find in math class. So whenever you need such kind of a basic mathematical operation, you will go here in the math class and you will see if something already exists. And if it's something like exponential or logarithm or the trigonometric functions, then you can find them directly here and you don't need a specific other dependency in your project to treat that power and so on. Let's talk about also a little bit about this random method. So this random method is designed to return a random value which is between 0 and 1. Here is where you also have to be careful. 0 is inclusive but 1 is exclusive, so we can basically returning to our IntelliJ here say that math random will return a value in this interval. So we have basically an inclusive for 0 but an exclusive for 1. So for example 0 something 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 can be one of the values possibly returned by math random, and we can simply even test it to see what it returns. Oops, it did add my system out but also deleted my comment. Very interesting. Looks like a bug in IntelliJ. Good. So I can now run, and you generate a random value. That means you will generate always a value that cannot be anticipated. So is always when you run you have a different value here. For example, now I have 0, 94 something something, and if I run again the same, then I will have a different value. The problem with this math random is 0.99 now. So the problem with this math random is that it basically uses only the CPU clock to generate this value. This is one of the problems, and the second one is that it's not really comfortable to use because you will only have a value between 0 and 1. So if you need, for example, an integer value, then you have to apply some operations to make this value to be integer. If you need some character values, you need to apply some other operations and define your own algorithm somehow that generates this value that you need. So it's not comfortable to use, and being that it only uses one variable to generate the to randomize the value, it's considered to be easily to anticipate with some mathematical statistical algorithms and using some powerful computers and some specialized software. You can basically minimize very much the interval in which the next value will be generated, and because of that you would not really like to use this method when it's really important that the next value that will be generated is really random. So imagine that you develop some gambling software, some gambling website in which the values really need to be random and cannot be anticipated easily, or at least not necessarily the exact value, because that's really difficult. But when I say anticipation, it means that you can minimize very much the interval in which the next value will appear, and sometimes this can be used to do some tricks and improperly use some specific application of this kind. So that's why math random, you have to know it. It appears in the questions of the OCP 11 exam. Basically, a long time ago, when I took one of my first certifications, it was actually a question something like, which is the only method in the math class that doesn't take parameters, and it was the random method. I don't think that this question really exists anymore. I didn't see it anymore, and I didn't hear about anybody else having that. But some kind of questions in the OCP exam can be really stupid, like why should I care that this is the only method in the math class that doesn't have parameters? Yes, one may say and one may argue that being that you know that you have actually used a lot the math class, but I don't know what to say. Is not really from my point of view, a good question, but you can expect things like this. So you have to know about math random, but I don't suggest to really use it. There are better options to generate random values, like the random and secure random classes from the Java util class, and we will see these classes, we will discuss them in one of the future lessons. So anyway, I can just put them in a comment here. So from the Java util class, usually you will, at least if you want an option from the JDK and you don't want to add some other dependency from the JDK, you maybe will use the random class or the secure random class. These classes from the Java util package are a better option, at least than the math random method. So we will see them at some point. If you want to test them before, you have now them. They are pretty easy to use to generate your random value. So if you need your random value until we manage to discuss these classes, at least what I can tell you is just go and try them instead of the math random method. Okay, so basically this is what we can say about this class, and I won't go into more details because we are losing time and I'm getting anyway boring. I have already bored you a lot with telling you stuff like which methods are important. You can anyway trust that they work okay and they return the correct results, so you don't have to worry about that. Before going further to the next class to discuss, I want to tell you only one more thing, and that's regarding the documentation itself, not the math class. If you observe here, we have the fields and we have the methods, but we have nothing else. And one might remember that any class in Java has also a constructor. So you always have one constructor in a class. It will be either one that you declare, either the default one that is that you have in any class in which you didn't declare your own. So where is the constructor here? This is the question. Why I can't see in my documentation here the constructor and the documentation of the constructor? Where this is basically because in the documentation of a Java class, the standard documentation of a Java class, you won't see any private members of the class. So in this is about any of your members of the class, even if it's a method or it's a field, you won't see the private methods or fields or constructors or other classes. You will only see either the public ones, either the protected ones. You don't see the private and you don't see the default. And that's why here, as you can see, we don't have any access modifier specified in the documentation. Well, when you don't have an access modifier specified in the documentation, it basically means that member it's public. So even if I don't see the public here, when in the documentation I have no specified access modifier, that means it is public. If it would have been protected, then I would have seen a protected here before. And we don't have any other options because the private and the default, they do not appear in the documentation. So the reason for why, for example, here in the math class, you don't see a constructor at all is because the constructor was made private such that it can't be called from outside. And this is because the math class is designed as an utilitary class. And in the utilitary class, we make the default constructor private, and that way we do not allow its call from outside of the class. So this is why you don't have, and always when you don't see a member in the documentation, it might mean that it is private. Okay, this is about the math class, and the next class that we wanted to discuss is the system class. So we have started with math and we go to system. Both of them are utilitary classes. Both of them are final, and they have the private constructor, and they only have static fields and methods. So math, which is designed for simple mathematical functions. system, it does actually represent the current system, and it has operations and fields that refer to the current system on which the current instance of virtual machine, of Java virtual machine, is executed. So let's see more about the system class. In order to see it in the documentation, of course, I can search it in the right upper corner, and I have the java.lang system class. This is the one that I want to discuss about. I click on it and now it's opened. Like any other class, it inherits from object. It is, as we know in java.lang, which is part of the Java base module, and it is a class. It is final because it is an utilitary class, and you don't see any constructor. That's because it was made private. We have some nested classes, but we won't discuss about them because they are not part of these fundamentals that we see, but we have some fields and some methods that we would like to discuss from this class now. It was part of Java since version 1, so it's again one of the oldest classes in Java ecosystem. In the case of the fields, we have here 3 static fields declared that you have to know. They are part of the basics of any Java applications, and as you can see, their names are ERR, in and out. So all of them, all 3 are streams, are IO streams, so input-output streams, and they represent the input-output streams, the standard input-output streams to the system. So out is actually one of the objects that we have used a lot in our applications until now. We have basically used this instance starting with the first lesson. It is always used when we are writing system out. So this out is this one here that you are statically referring to it from the system class. So this is one of the mostly used objects, at least when we have theoretical examples. When you do a real life application, a real case scenario, as you will see, you usually use a logging library, so you have more options there and you don't have to rewrite a lot of code to have warning levels and so on. But when you do and you start learning with Java, so one of the most used instances is this out here, which you see we have always used from the first lesson by referring to it statically from the system class system out. And then you can now understand easily that this is basically a behavior of the out object. So this is one of the methods declared inside the class that declares this stream class that is called actually print stream, and you can see the type of out is print stream in the documentation. This is also one of the things that sometimes I have encountered in the OCP 11 exam. Where is the print line method declared from the system out print line syntax? And a lot of people get it wrong, saying that this is declared in the system class. Practically you can see that is we use the referring dot operator here from the instance itself. So that means that print line is one of the behaviors of the out instance that is declared inside the system class using the print stream type. We won't discuss now about the print stream type, but we will discuss a lot about the print stream and input stream in general when we get to the IO streams chapter lesson in our stream. And being that the IO streams is not part of the first exam, that means that we will have this lesson about IO streams a little bit more in the future. So I won't get now into details. What I would like to tell you is basically what are these and what to remember about them. So out is the standard output stream. As you have seen, we have already used it a lot to write in the console, and everything that we wanted to output in the console, we have done that by calling the print or print line methods of the out instance. And similarly, we have that declared basically with the same type another instance called ERR that is called the standard error output stream. Theoretically, this is where you will print the errors, and it represents the stream related to the current operating system that was configured to get the to get the error logs. And so we separate simply the outputs from the errors that we want to log by simply the means of the instance of the output stream we use. And then we have this in, which could be used to allow the user to write in the console and to get some data that is written in the console. So to get the input from the console, we can use the input stream. It's the opposite basically of the output stream. Using the output stream, we put data in the console, and then using the input stream, you would get data from the console. The funny thing is that using directly the input stream, as we will see in that future lesson about IO streams, you will see that this input stream is basically a low-level stream, and that means that it allows you to read the arrays of bytes, which is not really necessarily comfortable to use because we like to work with strings, with numbers, with objects, and we don't necessarily see pretty often the information in terms of arrays of bytes, even if in reality we know that everything is basically an array of bytes, but we don't like to work with array of bytes generally. Sometimes we do, but in most of the cases we don't, and that's why we will not basically use this in stream very often just by itself. So the same that we do with the out, we use some classes, some util classes that can help us transform this stream in a high level stream that is more comfortable to use, that allows us to use directly, for example, information as a string. And because I'm here now, even if we didn't get to the part in which we discuss about streams, because I will in my examples from now on, sometimes I would like to be able to read information from the console. I think it's time to show you how to do that in Java. So let's create an example. So we have a second example here, and inside I will just write the second example class, and I will see you how easy using the system in and an utilitary class called scanner, you can read a string from the console and do something with it. So for this I will use a class from the Java util package, and I know we are not discussing yet about the Java util package, but I would like to show you how to do that now. So I use scanner, and I create this kind of scanner object that can take as parameter an input stream, and we use the in input stream from the system class that we know is the console input, so or the terminal input stream. And then it's pretty easy. You can have a line like a string, any string, just by using the read the next line method, and then you can do whatever you want with this line. I will simply write it in the console. So maybe let's just think this is a name, and I can even do something like this: system out print, and I request for the name first, and then I say hello, and the name that we have taken from the console. Okay, so this is how you read from the console a string, and then you can do whatever you want with that string. And in order to read it from the console, we need to use the system in input stream, so the one that we were discussing from the system class. So you see the system out is used to print something in the console, the system in is used to get something from the console. So if you run this example now, it should stop and ask for the input, and then I say I use an input, and then when I finish, I just press enter, and that means that a line was provided in the console. Then this next line will basically return the exact value that I have inputted here, and then the result will be hello and the name that I have inputted above. So very easy to use this scanner class to read from the console. This is how we read a string. It has dedicated methods to read the numbers, for example. Now we don't get in details with this, but you will see a lot of ways of using the scanner in my lessons from now on. And going back here to the system class, so basically let's assume that this is what for the moment you need to understand about these streams. Let's see also a few of the methods that you need to understand from the system class. So I will very fast talk you about the console method. That's because it's a little bit related also with the three streams that we have seen above. The fact that when you use one of these is not really easy to do a lot of things. You can do more things, for example, by using this console object that is developed to represent the console. And basically what you could do is to for example, above what we can do with system out and in is to read a password. So how is this console used is basically, let's write an example 3 for this, and it would be, that's the third example, and in the third example we say console C is system console, and then you would have to say something like if C is not null, and that's important to keep in mind, especially for your OCP 11 exam questions. This C can be null. The method was designed such that if you don't really call your application from a console, then C will be null. So if you see it in a question like directly used without having this validation here, that means that the code can throw a null pointer exception, which is that exception that is thrown when you call an attribute or a behavior from a memory variable that doesn't contain an instance. So we can say something like this, and let's run the application to see what happens when we run it from IntelliJ, and you actually see exactly that C in this case is null, and that happens because IntelliJ is basically simulating the console, is not the console itself. So that's why in this case C won't be a valid console object. In order to really be able to call this, I would have to go to the console and call my application from the console, and then C would not be null anymore. So keep in mind that the object returned by this console can be null. So if you have in a question, you might even have the situation in which the question tries to test you, that you spot there the null pointer exception. If not, then you can do some things like reading a line from the console, the same that we have done with system out and the scanner. But one thing that is rather more different is, for example, reading a password from the console. So I would not keep in mind all the things that you can do. Basically is reading from the console in general. So the console can be used to do outputs and inputs in the console, but you could at least keep in mind that this is maybe the most straightforward way in Java to create a functionality that reads a password from the console. And when I say reads a password, I mean exactly that functionality. If you worked with a console in any kind of operating system, you know, when it asks for a password that you type but nothing happens, it basically, you don't see the characters. you don't see anything being written, but you know that actually it happens, and then you press enter and the password was actually written. So this kind of functionality is what you would basically, for example, implement with this console class, and which really is straightforward implementing with the console class. Otherwise, remember that console class is for inputs and outputs, so working with the console, and remember this fact of the thing that if you don't call it directly from the console, then it will actually be null, as we have seen in our case here. So these are things that you can encounter in your OCP 11 exam questions. And then we have this current time millis, very easy to understand, very simple method. It only returns the current timestamp in milliseconds. So the timestamp is a long number that represents the number, depending on the case, the number of seconds or of milliseconds. In this case it will be millis, so it will be milliseconds, from 1970, so 1st January 1970. That is any timestamp that is after 1st January 1970, it will be a positive number. All the timestamps that are before will be a negative number, and you can test this method very simple in example 4. So in example 4 here, I will show you how to obtain the timestamp. The smallest and easiest example that you could do is to actually test the time of execution of a block of code. Is the easiest way you can do that on your local machine. Usually you don't do that to make a profiling on an application. You can use some tools for profiling, but if you just have an application on your own and you want to test a very small block of code for execution, you can basically do that by using the current time millis. But anyway, in the future, in one of the lessons in the future, we will basically learn about Java time package, and you will see that using the Java time package you work with dates and times, so you don't usually use the timestamp with current time millis a lot in applications. So yeah, you can say something like this. This is T1, and then you can say system current time millis, and that will be the timestamp at the moment of execution of the current time millis. So you can imagine that if you have basically something like method that takes a long time, let's say here called method that takes a long time to execute, and you want to measure the time, then you can take the time from before, and then you can take the time from after, and it's pretty easy just to do a T2 minus T1, which would be the time spent since the method started to execute and until the method ended its execution. Probably will be 0 in my case because I expect that it will be very fast, so I don't have anything in between. But if I would just add something in between, then it would be more than 0. So for example, let's say that we have something like this. Then maybe we see something that is greater than 0 in this case. So it takes a lot of time to, a lot of time, 3 milliseconds. But yeah, you got the idea what and how could you basically use this and what it does. So that's the purpose. So okay, going back. Then we have this really nice exit method. You have just to remember about the exit method that is used to close the current instance of Java Virtual Machine. So it basically closes your application. You call the exit method by providing an integer value representing a status for exit that could represent basically the status of an error that has closed the application. and you usually use 0 in case of on purpose exit. Let's say if that was the what should happen, then you do a system exit of 0, and 0 basically means that it wasn't an error for why the application closed. It was basically how it was designed to happen. And another thing to know about this exit is basically that whenever you have a process starting your application, your Java application, that process starting your application can obtain the status value. So if it was directly the operating system, then the operating system can obtain the status value. If you have another application that starts your application, say in Java we can, and like in any other programming language, we have the possibility to start processes. You can create applications that start other applications. As basically when you do something like this, you can keep a reference to that process, and if that process ends, then you can get back the status, which is the value that was provided by that process which closed. So for example, in our case, it will be this status. So you can this way know what happens with a process that was started by your application. This is not necessarily a trivial thing, so you don't have to think now a lot about it. I just wanted to give you the context of a use case of this exit method, rather than only being the method closing the application, and also to understand better why is that status there. It really has a purpose. It's not there just because it's a number that had to be printed somewhere. So and we will see that exit basically it's also a special method when we will discuss about a try catch finally structure. You will see that there is a block called finally, and that finally block basically executes almost always, and it has only a few situations in which it doesn't execute, and one of them will be related to the system exit method. So at that point I will refer back to this method. And basically beside this, because the rest is not really important from my point of view, the only important method here that we will have to discuss further, but it won't happen today, is the GC method, which actually comes from garbage collector. And the funny thing is that it's not my purpose to discuss the method itself, because as you will see, mostly this method does nothing in Java. It's a really funny method. I'm really thinking sometimes about whoever developed this method, what were they thinking in developing this method, because it simply almost is almost doing nothing. We will discuss rather about something more important, and that's the garbage collector. So I always, when getting to this method, because it's referring to the garbage collector, I take the opportunity here to discuss about the garbage collector, and that means also referring to what means the memory management in Java. The garbage collector is basically managing the memory and making sure that it cleans the memory of the applications such that the space can be reused for other things. It's a really nice subject. It's an important subject, and in the next lesson I will take the opportunity to discuss a lot about this garbage collector. So I have seen now your question, Andrei, when exactly we will discuss the GC concept. This is basically in the next lesson, so now we only have 3 more minutes. I will need at least the next 1 hour to discuss about what is the Java memory, how is it structured. We will discuss about stack and heap. We will discuss about how the heap memory is structured, and we will discuss about the garbage collector. Yes, basically it is important to know it, and it's one of the subjects that is really complex. So 1 hour would only be to cover the fundamentals from this aspect, and this will be, so basically next lesson we discuss about it. but if you want to go deep into details with this concept, you will basically see that you will find books of hundreds of pages discussing the garbage collectors. There are multiple garbage collectors. There is a history in the evolution of the garbage collector. The last garbage collector was released in Java 13, so in the last version is called Zero Garbage Collector, and it's with almost each version of Java a new implementation of garbage collector was also released. Honestly I don't know them all, and all of their functionalities. Always when having something to deal with garbage collector, if I need some more information, I have to read the details about them, because I only know the basic implementations, like the G1 implementation. Now it's acting, and of course I will tell you more about all this in the next lesson, but it's a really complex subject. But at least the promise is that in the next lesson we discuss all the fundamentals, starting from the memory structure in Java. So how is the JVM dealing with the memory, to the garbage collector and the way the garbage collector works and what is its purpose. Okay, basically I think this is it. So I have done everything beside this, because I have skipped it exactly because I knew I need more time to discuss about the garbage collection. So this is what we will continue with in the next lesson. Do you have any other questions, or can we end with this live stream? I think we have covered, we have started, we have a good start with the java.lang now, and we have discussed on math, on a system class, and now we will continue with this garbage collector thing, and then with all the other classes from the java.lang. So that would be, we have to discuss after that about object and overriding methods from object, and then we'll have the wrapper classes. We have the string management, which has to do with memory as well, and is really important. And again, you will find it in interviews for especially for junior positions, but junior job roles. But they can be basically in any kind of interview. And then of course the exception hierarchy. So yeah, all of this will be basically will take us the next 3 or 4 lessons to discuss about all of this in the end, as you will see. Again, thank you very much for watching, and hope to see you for the next videos. Thank you and have a great evening.